Hello everyone. Today I'll do a little demo of connecting a digital oscilloscope Rigol DHO900 to ngscopeclient. Very easy and I think very pretty cool. Alright, so first we're going to launch the application. We'll get some warning because it's creating some configuration folders. And let's get a bit of a space down here to see a bit of a task manager, network traffic. Alright, so we're going to add the oscilloscope. Very easy. Oscilloscope connect, in my case is Rigol 900. We need the IP. Click here in the corner and we can get the IP. Apologies for the quality of the video of the camera. This camera is not good to shoot close objects. Something to improve in the future. Alright, very easy. It has detected the oscilloscope, the channels. It's going to default with the configuration settings we have running at this time in the oscilloscope, which is useful. The sample rate and the size of the waveform. And to get a signal, I'm going to use initially this output that we have in this oscilloscope to calibrate the probes, which is a square signal of 100 kilohertz frequency. Very simple, very easy. And something we can do first is to just take a shot. We go here in the symbol on the left, and first it looks like nothing happened. We see a weird yellow line over here, but that's because we need to adjust our view in the client with autofit and autofit. Alright, very simple. We can see now here the same waveform we can see in the oscilloscope, and we can do a small measurement. Measurement frequency. Yeah, 1 kilohertz as expected. Let's put it here in this corner. But that's not interesting. We would like some interaction, some motion. So let's press play. And now in real time we're getting the waveform from the oscilloscope, and it's going through the network. We can see a bit of traffic down here and going into our client. We are controlling the oscilloscope from here now, and we can see this if we zoom in or zoom out. We can see how the changes happens also in the oscilloscope. There is a bit of delay on the video. You have to take my word on this one. The change happens in real time, but for my laptop is struggling a bit running the application and recording and at the same time. We do autofit again, and we stop. Easy. But let's get a more interesting signal. I'm going to unplug the probe. and I'm going to plug the signal generator that this was a simple signal generator that this oscilloscope includes. Let's start something easy. Let's start with 1 megahertz, and we run auto, so we can see it here running on the oscilloscope. And now we press play also in ngscopeclient. Same issue again. We need to auto fit. Easy. Now the frequency has changed. And it's around 1 megahertz as we anticipated. Yeah, we can see the oscilloscope triggering between single and run over here. Not sure. I'm not sure why is this happening. Also, we can see in the screen that is not executing seamlessly. There's maybe there's some configuration changes that I need to do. Perhaps we're sampling with too big a memory depth. We can try to change it. The network traffic reduces, but it's still doing this flapping, which means that something is not completely right in this configuration. Anyway, we'll find out. So now that I have a nice sine wave, let me get some statistics. Rendering, which is not great. So my laptop now is struggling with this frame rate. It should be better. And in fact, it's better when I'm not recording high quality video at the same time. Down here, this value is kind of expected. These 3.2 waveforms per second. According to ngscopeclient documentation, that's expected for this oscilloscope. Here, the bottleneck initially on this stream is the oscilloscope itself, the capacity that it has to send over the network waveforms that we can read over here. We can add something more fancy like an FFT. Auto feed. So we have our megahertz down here and expected a number of harmonics. And we can do a bit of experimentation. So what happens if we go from 1 to 10? So there we go. We can see how the spectrogram is changing. And we can see a nice collection of harmonics, 10, 20, 30, 40. Pretty nice. And here we have our signal. So yeah, I think that's it. Quick demo. Some work pending to do on my side to try to understand why we have these little stops and runs with this oscilloscope, and here it is. I hope you like it.